At this stage, we're pretty much feature complete, but there's an awful lot of optimization and security work that needs to be done before we launch the public network. So, for example, we've got some very talented security people, and one of them found that you can use WebAssembly to run side channel attacks. So, we're digging deep, and we're looking for just about every perverse attack that's possible, and it's going to take a couple of months at least before we're happy to launch the network.
That's a great answer, Dom. And something that I do see asked quite often in the community is to what extent the Dfinity Foundation will be working with people out in the community or maybe independent auditors to really make sure the network is secure before it goes live. Are you able to speak to that a little bit more?
Yeah, sure. So, the Internet Computer is a very complex project, and it involves a lot of, if you like, high science. We're developing new cryptography and new protocols. Pretty much everything's new. And that means the investment you need to make before you really understand what's going on is that much greater. So, first of all, it's very important that we ourselves hire full-time security experts that can, really go to town on this and invest the time necessary to make it safe. However, of course, we also care enormously about community pen testing, but that's going to happen at a later stage near launch.
Got it. So one thing that people in the chat may not know, maybe some of them, that the Dfinity Foundation was founded back in 2016. And back in 2016, a lot of projects out there could really only dream of just creating a faster Ethereum, so to speak. But here at Dfinity, we've clearly taken a different path, and we've set ourselves on this really amazing vision. And I would just love to hear you speak to why choose to build the internet computer versus kind of focusing on that mission of just building a faster Ethereum?
Well, the vision was always to create a sort of web speed, infinitely scalable blockchain that could host the world's software and data. And we've stayed true to that. That's why the project is called Dfinity. Dfinity is just a shortening of decentralized infinity. So, that's what we set out to do originally, and we haven't deviated from that plan. I think generally, the Internet Computer represents the third great blockchain innovation. The first was Bitcoin, the second was Ethereum, the third is the Internet Computer. All of them are very different things. If you look at the way blockchain has evolved historically, and when after Bitcoin came out and everyone was obsessed with it, and that was the latest and greatest, if you like, or the first and greatest. We had all of these altcoins. You had Litecoin, Feathercoin, hundreds of them, in fact. Where are they now? Most of them have disappeared, right? They were just copycats. And, then we had Ethereum, and that's proven hugely successful and was completely revolutionary in its own way. And, it's no wonder then that we get all of these copycats. Everyone's out there raising money on the proposition they're going to build a faster Ethereum and do Ethereum 2.0 before Ethereum and so on. We don't want to be, we're not a copycat project. Everything in the Internet Computer is developed from scratch, is completely novel, it introduces new ideas. And, frankly, it takes us to a place that most people still cannot even imagine. It takes us to a place where we have a blockchain that, should be capable of hosting the world's software and data. And that means that for the first time, people are going to be able to build websites, enterprise systems, internet services on a public platform. We've taken, the idea of blockchain, the Bitcoin introduced, where a public network created this virtual platform. In the case of Bitcoin, of course, it's just a very simple ledger. In the case of the Internet Computer, that ledger has transformed into a sort of platform for software that executes in that single tamper-proof trust environment. So this is transformative. People are going to be able to build websites, enterprise systems, internet services on a public network rather than on closed proprietary systems like Amazon Web Services. And this is something very different to a cloud too. This is something completely new. People can create autonomous software. They can process value and data value and identity as data, and just do things that you just simply cannot do today. And of course, the internet computer is going to mean that things that we've struggled to do in the past on blockchains like Ethereum suddenly become very easy. So that's why, we took on the challenge. It was always our vision to provide the world with this functionality and not just produce a faster blockchain, but actually provide a public network that can act as an alternative to legacy IT. And, the internet computer reinvents software, reimagines software, and we introduce things like orthogonal persistence and so on. So, we're really trying to reinvent many different things, not just blockchain. We want to replace legacy IT.
Got it. And Dom, so knowing that, we've been working on the Internet Computer project for about 4 years, and we're just now coming up on public launch in the next few months, it's very likely that it'll take us many more years to fully realize the vision for the Internet Computer. So to individuals out there watching right now who may be thinking about joining the Dfinity Foundation or joining the Dfinity team to work on this, what would you say to them to kind of get them across the line and remind them why they should be submitting those applications and thinking about working with us on these problems?
Well, first of all, the Dfinity Foundation is working on some of the most exciting, cutting-edge computer science around anywhere. We're working on programming languages, virtual machines, distributed computing protocols, advanced novel cryptography. You name it, it's here at the Internet Computer Project. So, if you're an advanced software engineer or researcher in a relevant area, this is an absolutely, if your passion is for computer science, this is a great place to work. If you're a community member thinking of building something on top of the Internet Computer, I put it this way. First of all, I don't think the next generation of kids is going to be building on Amazon Web Services. Once they find out you can just write code to the internet and it's tamper-proof and unstoppable, it requires far less code to create a scalable, hyperscale internet service such as Instagram. They're going to just want to write code and push it to the internet. If you're an entrepreneur, it's 100 times easier to surf a wave than it is to paddle out. Building on the Internet Computer is surfing a wave. I think things will develop much faster than people expect. I mean, look, here at the Dfinity Foundation, we're in this for the long term. We're going to be improving the Internet Computers, working on alongside other foundations being created now, by the way, working on improving the Internet Computers protocols and technological implementations. But I think we're going to start seeing exciting internet services appearing pretty early on, because this uncorks the blockchain genie. Now people won't be limited by gas costs and scalability and speed. They can serve user experiences directly from the blockchain, from cyberspace into browsers, and this is a game changer. So, for example, we've already got a bunch of amazing projects being built on the Internet Computer. Everything from very serious games through to pan-industry systems. This is going to be a big thing. So don't wait around. This is your chance. Surf the wave.
Speaking of the games, we're going to come back to that in just a moment with a quick question. But one thing I wanted to chat about, often out in public, people notice us relay ourselves to organizations like DARPA and CERN. And can you just share a little bit more on why we tend to make that connection out in public?
Well, we see ourselves as a very serious research and development organization, and the team has a lot of very brilliant researchers and engineers, and we're trying to extend the internet. We're also trying to redefine the internet, from just being this public network that connects everyone to being a public compute platform that hosts the world's systems and data. So, we're definitely part of that tradition. I think what's so exciting is that the internet was created because of the impetus of the Cold War. A lot of money was poured into its development because, the world wanted a communications network that could withstand a nuclear strike, and when the Cold War passed, the funding sort of dried up, and, the internet since then really has only seen incremental developments, and which are, pursued by, researchers at universities and so on. There isn't really the funding there to take it on the next step. I think one of the fantastic things that blockchain sort of achieved was providing a way to fund the development of public networks. And of course, the internet's a public network. So, we're like, okay, let's extend the internet with the internet computer and fundamentally transform what the internet's about. And I think in the future, in the same way that people won't think about all those private networks that their data flows across when they're connecting to each other over the internet, they won't either think about all of those individual node machines running in independent data centers around the world that are creating this internet computer platform, which of course is an entirely virtual thing, for the developer and user. They don't have to know anything about the individual data centers and nodes behind it any more than you need to know about the private subnetworks in the internet when you transfer data over it.
I wanted to take a moment and switch gears a bit to start talking a little bit more about governance of the internet computer. So as you know, today we shared a little bit more about what next steps look like for people who have been participating in the airdrop. And aside from utilizing their ICP tokens in the future to participate in governance, and of course utilize that ICP to create cycles to run their software on the internet computer, we wanted to see if there was a little bit more that you could share about exactly how neurons work and why it's so important that we have people out in the community creating neurons and participating in the governance of the internet computer.
Yeah, well, simply put, the more ICP tokens that are locked in neurons in the network nervous system, the more secure it is. Obviously, a fear would be that some party would purchase a sufficient quantity of ICP and lock them in neurons that it could control the network nervous system or influence its decisions on proposals in a way that's detrimental to the network. Now, it's very unlikely any individual would want to do that, of course, because they'd be investing a huge amount of money in these ICP tokens only to lock them inside the network nervous system and devalue them. So in practice, this is very unlikely. But all the same, I mean, the more community members that acquire ICP tokens and lock them in neurons and configure those neurons to vote either by manually as a result of them voting or automatically as a result of other neurons that they've chosen voting, the better, the more secure the network will be.
Let's chat a little bit more about the network nervous system. So are you able to share a little bit more about the functionality and the properties of the network nervous system that you expect people to be interacting with at launch? And then perhaps could you share a little bit more about what you imagine the network nervous system to look like in maybe just a few years?
So that's a really good question. First of all, the network nervous system is fundamental to the functioning of the network. Okay, so the internet computer scales out by creating new subnetworks. And new subnetworks are obviously created by drawing nodes from independent data centers around the world. That process is actually driven by the network nervous system. So the network nervous system is fundamental to the functioning of the network. So that's just one kind of network management function, but there are lots of other functions. It's involved in the economics of the network, potentially even other areas. When you create a neuron, you can configure it to vote automatically on some topics and not vote automatically on other topics. So, for example, most people will configure their neuron to follow various foundations or the neurons of various foundations and leaders in the space with respect to network management, because they won't want to be, looking at all of these proposals that come through all the time. I mean, they could come through very, very regularly indeed. But they might decide they want to vote manually on for example, a protocol upgrade that's going to introduce a major change to the way the network works. So I think the network nervous system, because it is open and algorithmic, is going to create, it's going to be very entertaining to watch it evolve and how its role, I think it's going to change over the years. I mean, in the end, I mean, the network nervous system has the ability and will all the time push updates to the ICP protocol and the software that's running on the nodes. And so in a sense, it has absolute control of the network.
Got it. So Dom, on the same topic of governance, I want to pull a quick question from the community. So how does the internet computer ensure that it won't be privatized when it's being built by a private foundation? And does the Dfinity Foundation plan to remove itself as a moderator at some point?
Well, first of all, the Dfinity Foundation is a not-for-profit Swiss foundation, and a not-for-profit Swiss foundation cannot have members. That means there's no stock. The foundation has a purpose that's described in something called a notarial deed, and that specifies what it can do. So the purpose of the Dfinity Foundation is to develop the ICP protocol, to develop technical implementations of the ICP protocol, such as the software running on those nodes in data centers, and to promote the usage and adoption of the internet computer network itself. And that's all it can do. So Dfinity Stifting, the Dfinity Foundation, is really a terminator. It cannot be acquired because there are no members. All it can do is pursue its purpose in the notarial deed like a kind of terminator. It can't even pivot. If the world decides that the internet computer is a terrible idea, makes no difference. The Dfinity Foundation will just keep on marching on, trying to make ICP and the implementations of ICP better and encouraging people to use the internet computer network. And there are some other organizations which I can't announce quite yet, but the announcements are coming soon, which will also play similar roles within the internet computer ecosystem. So people need to have absolutely no fear that the internet computer, either the organizations involved in the ecosystem are going to be privatized, or the actual network itself will be privatized. In the end, you can't privatize a protocol, right? I mean, you can't privatize the Bitcoin protocol, and you can't privatize ICP. And as the years go forward, there'll be more and more independent data centers, running these specialized hardware nodes that connect together over ICP to create the internet computer. And there's absolutely no chance that anyone's would be able to or want to privatize it, because the value of the internet computer largely, it's not just about the technical innovations and the way you can create things like scalable, tamper-proof code. It's also about the fact that the internet computer is a public platform. We don't want to build AOL, we want to build the internet.
So Dom, today we saw a bunch of really great presentations from Dfinity team members all over the world. But one presentation that I've noticed has caught the eye of many community members was today's presentation on Big Map and Big Search. And I would just love to hear from you, what is it that excites you the most about Big Map and Big Search, and especially getting those tools into the hands of developers that are looking to utilize the network?
Well, I mean, first of all, of course, the reason we're called Dfinity is we're pursuing decentralized infinity in a sense. We're trying to enable the world to build all its software and host all its data on a blockchain, a public blockchain. And, I think Big Map and Big Search demonstrate the sort of progressive realization of that vision. Another part of the vision actually relates to my own background. I created systems that had to scale in relation to a game I created, which had some millions of users. And I'm very interested in distributed computing and scaling and so on. And also, I've been programming for many decades now. I won't say how many. And I've always felt there was something, wrong with the legacy IT stack and didn't like various aspects of it and felt there must be a better way. And, I want people to be able to create Instagram or WhatsApp or Facebook, as an open internet service, which is controlled by a tokenized governance system, but also in far less lines of code. And I think this is a very key point that a lot of people miss. It's not just about creating a blockchain that can process an infinite number of transactions. It's about enabling developers to create systems that scale. And we want to do that far better than the legacy IT stack. And I think with the canister framework, the way that our code can reside within this infinite universe of software, we're achieving that. But there are always going to be some complexities with creating a hyperscale internet service, and we don't want developers to have to deal with that. So part of the magic of the internet computer is that you can create interact with an object that interacts with other canisters, right? Which are just kind of like these things called actors, which are the kind of objects of the internet computer, and ultimately every actor has its own memory, which can have up to 4 gig of memory. So you can get the illusion almost that you have infinite memory and create something like a hash map that stores exabytes of data. And that's what we're going to give people essentially with Big Map and Big Search. We're going to give people a very simple kind of collection object that allows them to store vast amounts of data. And actually, I didn't think we were going to get a Big Search ready for Sodium, but Sasha made huge progress with it. And so, that's also very important for developers creating internet services. Like, it's all very well having creating open Facebook or something like that, but you have to be able to search for content, right? I mean, actually, we need to retrofit this to Linked Up, which we demonstrated in Bronze, because in that case, you didn't have a scalable search system. And of course, if you want to have a professional profile network, potentially you'll have very many millions of professional profiles.
So Dom, one more question on scalability, and this includes cycles and Ethereum as well to some extent. So, as we've seen the rising gas prices on Ethereum and it, acting as a barrier to scalability for some developers that are building projects on that network, can you share a little bit more about what gives you confidence that this won't be a problem on the internet computer, especially as it relates to some of the more computationally intensive projects that people might be wanting to build, such as video gaming and others?
Well, remember that Ethereum is a finite resource. Okay, so today's blockchains don't scale out. That means you have to have a way of mediating which transactions get into blocks, and that's why we have things like fee markets on Bitcoin and Ethereum. And if lots and lots of people are wanting to submit transactions on Ethereum, the fee market decides whose transactions get in by raising the price. And I think recently I heard that it's like $75 to submit a transaction to Augur. So the internet computer is a very different kind of blockchain. It scales out horizontally, and it's not a finite resource. And for that reason, cycles have a fixed cost. They're a kind of stable coin. So, cycles being the equivalent of gas on Ethereum, and you can buy them at a fixed cost for all time. And as time goes on, the number of cycles consumed by computation will fall because, of course, the underlying hardware gets faster. The difference is enormous. If the internet computer runs out of capacity, it doesn't raise the price of cycles. It just adds more nodes. And to begin with, of course, we need to make sure the network is sufficiently large that we don't get caught out by variance. And that's why we already have hundreds of nodes running. Initially, there's always going to have to be quite a lot of headroom. But eventually, of course, the law of large numbers, the same thing that makes the internet more efficient every year, will allow that headroom to be brought down. But that's how the internet computer works. Cycles are extremely cheap, and when the internet computer is getting short of capacity, more nodes are added to the network rather than the price of cycles going up. And to be absolutely clear, the cost differences are absolutely staggering and enormous. It will cost you $4 to $6 million to store a gigabyte of data on Ethereum, and it will take you a very long time to get that gigabyte of data onto the chain. As we've seen from the Big Mac demo earlier on, it doesn't take very long to get a gigabyte onto the internet computer. And I can't tell you what the final cost is going to be in cycles right now, but with a fiduciary subnetwork, the cost per gigabyte of the hardware itself is about $10. But we've got other kinds of subnets which will be specialized for storing data, which will bring that down. So it'll just be a few dollars. It's a bit more than a traditional cloud, but at the end of the day, the biggest expense you face as an entrepreneur or developer is actually developer time, and that comes from complexity. And the internet computer enormously simplifies the task of developing internet services.
So Dom, there's a community question here that I absolutely want to ask, and it's relating to sustainability. And the question is, data centers, of course, require a lot of electricity. Is there any plan for the Dfinity Foundation to partner with data centers which are sustainably run, or perhaps is there anything else that you might want to share on this as it relates to the way we are working with independent data centers?
Well, remember, firstly, the Dfinity Foundation doesn't control the internet computer network. The internet computer network is controlled by the onboard in-protocol algorithmic governance system, the network nervous system. So a data center that wants to join the network and be able to add nodes or submit nodes that can be inducted must first get a data center ID. So they actually apply to the post-launch. They have to apply to the network nervous system. The Dfinity Foundation won't control the internet computer network. It'll obviously have an influence within the ecosystem, just like the Ethereum Foundation does, but we won't control it. But I think there's two parts to this question. The first is, look, I think everyone, governments need to tax electricity, and that will drive data centers to seek greater efficiencies. And of course, we hope that happens. But aside from that, I think it's very important to recognize that legacy IT actually uses a huge amount of electricity. Now, we look at legacy IT and we see replication everywhere. We see replication of data between the index and data file of databases. We see master-slave. We see memcached. We see content distribution networks replicating data all over the world, and so on. So when you look at legacy IT and you look at the lack of consolidation and the silos, and it's horribly inefficient. We believe by moving the world's websites, enterprise systems, and internet services onto the internet computer, even though it as any blockchain does, it uses replication for the purposes of security and so on, it can reduce the electricity consumption of all of that stuff that's currently built on legacy IT. And of course, when you're looking at traditional blockchain like Bitcoin or Ethereum, I mean, that actually works through these kind of electricity burning competitions. Like proof of work is an electricity burning competition. The more electricity you burn, the more hashes you perform, and proportionally, the number of blocks you produce reflects your share of the electricity that's being burned, right? And I mean, there's different, people will give you different accounts of how much those two networks consume currently, but it's anywhere between, 0.5% and 1.5% of global electricity production. We hope the internet computer will demonstrate to the world how a blockchain can be more secure than those existing networks, which suffer from centralization in mining pools and things like that, be more secure than and more reliable than traditional blockchain networks, and yet consume a tiny, tiny fraction of the electricity per unit of compute performed. So we hope the internet computer will play a fundamental role in reducing the electricity consumption of IT and helping the fight against climate change.
Got it. So Dom, we have just a few moments left, and I want to take a couple of community questions that relate to both strategy and the big tech narrative. So the first question I want to ask is really around what is Dfinity's strategy for competing with incumbents like AWS, Microsoft Azure, Google Cloud? Why should someone really consider building on something like the Internet Computer, or maybe even attempting to port their project over to the Internet Computer versus these more established organizations?
Yeah, so first of all, Internet Computer versus Amazon Web Services sort of works as a comparison, but it doesn't really. They're very different things. The Internet Computer enables you to do things that you cannot do on Amazon Web Services. Imagine trying to do Bitcoin, create a digital currency on Amazon Web Services. Well, first you get a, contract with Amazon Web Services, then you create a single, some kind of cluster of machines on Amazon Web Services that host the ledger. I mean, no one would be interested in it, right? People are interested in blockchain because, first of all, you're building on a public network. Secondly, it's tamper-proof. Thirdly, it's unstoppable, and so on and so forth. And including, of course, that you can, process, value and identity as data. So these things are revolutionary. Look, I mean, I think we're going to see a huge number of people that want to create open internet services. Everything from games, games, open Salesforce, open Facebook, you name it. We're going to see a vast range of open internet services on the Internet Computer. These will have enormous advantages compared to traditional internet services. They'll be built from autonomous software that is controlled by tokenized governance systems that run as part of the fabric of the internet itself. They're going to be able to guarantee, they're going to be able to trustlessly share functionality and data so that you get what's called service composability, and entrepreneurs can build on each other's systems without having to trust each other. And of course, users are going to get a much better deal with respect to things like transparency. But if you're an entrepreneur outside of Silicon Valley, or even in Silicon Valley, and you want to create a new social network, well, good luck going to a VC and trying to raise money for building a traditional social network that's going to compete with Facebook. But an open internet service is a completely different kind of thing to a traditional, internet service run by monopolistic big tech. And it has a number of killer features that you just can't get from those kind of services. So, all of a sudden it becomes viable to do something like that, to reinvent the internet ecosystem. So that creates greenfield opportunities for entrepreneurs. Also, the tokenization of services is going to provide ways for developers around the world to raise money, hopefully in much more responsible ways than we saw with ICOs, but to raise money to develop the future internet ecosystem. So, rather than just the 0.5% of the world's developers in Silicon Valley having a shot at developing important new internet services, pretty much anyone in the world, if they can get a talented enough team together and build a fantastic prototype, is going to be able to convince people to possibly fund what they're trying to do. So it's going to distribute opportunity around the world. And in turn, that's going to unlock an absolute treasure trove of talent. It's just a myth to assume that, all of the talent's concentrated here in Silicon Valley. Talent is distributed around the world. It's just that, even if you're located in somewhere like London, it's very, very difficult to raise money compared to Silicon Valley. So this has the potential to sort of uncork the genie of worldwide talent. And that's another big reason that entrepreneurs should think about building open internet services rather than banging their head against a brick wall trying to beat big tech at its own game.
So Dom, I have just a few more questions for you, and it looks like we're pretty quickly running out of time. So maybe we tackle these ones, quite quickly. So this is actually a really interesting question from the community, and it's, what's not possible to build on the Internet Computer?
Well, that's also a really good question. I should say, first of all, that over time, there'll be different generations of subnetworks that use different kinds of hardware. So, what's not possible now may become possible later. And a good example of that is AI. You can certainly run AI and Bayesian classifiers and so on the Internet Computer. But if you want to create neural nets, you may have a disadvantage. Well, you will have a disadvantage against, for example, Google's TensorFlow cloud. So, that's an example of something that wouldn't be competitive to build right now. Obviously, over time, we will address those kind of needs, but that's not what you'd want to be building right now. You could certainly build, various MMO games on the Internet Computer. if you wanted to build some kind of point of view shooter like Call of Duty, that'd be harder. Albeit there are probably ways of doing it with query calls and things like that, which I haven't thought of. But there are lots and lots of things that you can build right now. I mean, you can stream video, you can create scalable internet services, and you can create software as a service type systems like Salesforce. I mean, honestly, there's so many things that are there to be created by entrepreneurs. Inside, actually, we didn't have time to do it. I wanted to create something called Rainforest, which was like a decentralized Amazon as a sample app for Sodium, but just didn't have time.
Yeah.
Everything. There's a whole world of opportunity.
So, Dom, my last question for you. Should we find success here at the Dfinity Foundation and the world with the internet computer, what's to stop a larger player out there in big tech from spinning up their own internet computer and sharing that with the world?
Well, firstly, the idea of big tech running the internet computer or building it itself is kind of antithetical to its purpose. The world didn't want AOL, CompuServe, or Microsoft's internet information superhighway. They wanted the internet. They wanted a global public network, and that's also true of the internet computer. People don't want Amazon Web Services. They want the internet to be the compute platform. And all of those independent data centers that will participate in the network will probably have second thoughts if it were actually somehow controlled by big tech. So I don't think we have to worry about that one.
Dominic, thank you so much for joining me here today and agreeing to take some of these questions from the community. For everyone else that's watching, as you know, during the Tungsten event, we opened up the network to third-party developers for the very first time. Now, with the closing of the Sodium launch event, we are going to be opening up that network to everyone. So the people who are interested in developing projects and applications on top of the internet computer can now begin sharing those projects with the world, bringing on users, getting people testing their applications, and really seeing how this thing works. We'll also be introducing wall canisters and cycles. So do please go to the Dfinity website to learn a little bit more about that. And you can do so by visiting dfinity.org/sodium. Thank you again all for joining us today. If there's really one thing to take away from this, it's that we really want you to get out there and start building. And for those of you who aren't necessarily developers or you don't know developers, now is a really good time to start taking a look at the projects that people are building. Things like Sailfish, Get Impact Now, and we'll be sharing so many others with you from our end here on the community side. So please do take a look at some of the things that people are building. I think you guys will be pleasantly surprised what people can build with the internet computer. Thank you, Dominic. Thank you, everyone.
Thanks, Mike. Thanks, everyone.